Hello dear student, I am Mohammed Islam. Today in this video we are going to discuss an important question from CSIRNET 2021, June 2021, okay, which happened on February 2022. This is basically a question from part C and question ID is 522. Okay, what is the question? It says if A is an enclosed matrix, we say A is diagonalizable if there is a non-scalar matrix P such that P and P inverse is diagonal. Okay, then there are four options given. This first option, this second option, this third option, this fourth option. Okay, the fourth option given. There is, it says there is a case such that it is identity, then does it imply A is diagonal? See, for option 1, for all option. Okay, it says it were K equal to identity. Okay, for some integer, obviously positive integer, z plus, for some integer K, then does it imply A is diagonal? From here you can write that it inherit a polynomial x, but write fx is equal to s to k minus 1 is the inherited polynomial, inheriting polynomial of the matrix A. Okay, now we all know that minimal polynomial of the matrix of a matrix always divide the inherited polynomial fx. Okay, now we want to know what is the root of this polynomial equation. If you want to find this root of this equation, so you have to solve this equation, x from k minus 1 equal to 0. So you have to solve x to k equal to 90. Okay, so you have to solve x equal to 1, write 1 plus 90 0 1 to k. Okay, so put it cos 2k to m pi, because cos 2 m pi is 1. Okay, cos n pi is minus 1 to n. Okay, for n belongs to natural number. So cos 2 m pi will be minus 2m is 2, minus 2 means 1. Okay, so cos 2 m pi is 1. Sin 2 m pi is 0, because in multiple of, if it multiple of pi into k pi, sin k pi is 0, so sin 2 m pi is 0. So you can write 1 in place of cos 2 m pi, in place write 0 sin 2 m pi power 1 by k. Okay, but m is an integer. See, you can write like this by De Moivre's theorem, cos 2 m pi by k by I sin 2 m pi by k. Okay, now m vary from 0 1 to k minus 1. Okay, there are k values are n. If you put k equal n equal to 0, then you get cos 0 1 sin 0 0, so it gives 1, so root will be 1. And if you put k equal to m equal to 1, so you get cos 2 pi by k plus I sin 2 pi by k. And similarly you get k distinct root. Okay, k distinct root, and all are member of C. So obviously this equation has distinct root and root are in C. So this polynomial equation has distinct root, and what is this polynomial? It is inherited polynomial of A. Okay, so if this polynomial has distinct root, then polynomial divide this polynomial, so it is obviously a distinct root. Okay, it obviously have distinct root, and root belongs to C. Okay, maybe in linear factor, because its factor will be either x minus 1 like this, or x to k minus 1, or x to k minus 2 plus so plus 1. Okay, so linear polynomial maybe x minus 1 or this. If it linear polynomial, if x minus 1, then matrix become INT, because linear polynomial satisfies the matrix. Okay, so if you put in place of x equal to a, so you get ma a equal to 0, ma what x equal to a, so you get a minus I will be 0, a equal to I. So if linear polynomial is x minus 1, then the matrix will be INT and is diagonal. Okay, but the linear polynomial, if x is this, the linear polynomial is this, then it has distinct root, and linear polynomial may be this product of these two. Okay, then also it is a distinct root, because one root is 1 and other root is complex in the format of like this, cos 2 m pi plus I sin 2 m pi, in this format. K varies from, so m varies from 0 1 to k minus 1. Okay, so first one root is 1 and other root is of the form cos theta plus I sin theta. Okay, this form. So and all these all are distinct. Cos 2k pi plus I sin 2k pi. Next one is m equal to cos 4 pi by k plus I sin 4 pi by k. Next one is in plus m equal to plus 3 put 3, so cos 6 pi by k plus I sin 6 pi by k. These are distinct root. So so the matrix have distinct root, and also the root are in C. So obviously the matrix is diagonal. Okay, obviously the matrix is diagonal over C. Here also in the question there is no mention of field. Okay, no mention of field. So you have to consider the field is C. So I proved that the matrix is diagonal. So a to k is int, if a to k into int whole for some integer k obviously positive integer, then A is diagonal. This option is correct. Okay, now go to second option. Second option says there is integer k such that it equals 0. Okay, a to k equal to 0 means A is nilpotent. Okay, we know a result for option 2. We know a result, no non-zero nilpotent variable, no non-zero nilpotent, no non-zero nilpotent matrix is diagonal. No non-zero nilpotent diagonal. Only zero matrix is the nilpotent matrix is diagonal. So he says a to k is 0 means A is nilpotent. H nilpotent, right? But may be a 0 or non-zero nilpotent. Okay, so if it is 0 then diagonal, but if it is non-zero then it may not be diagonal according to this option, because no non-zero nilpotent is diagonal. So I am choosing a non-zero nilpotent matrix 0 and 0 0. Okay, it is very important because if you square this you get 0. If you square this you get 0 matrix. Okay, so it is nilpotent matrix. So for k equal to 2 it gives 0 matrix. Okay, so for k equal to 2 it gives 0 matrix, but it is diagonal. This matrix is not diagonal, but this is non-zero nilpotent matrix. How you understand it is nilpotent? Because its power gives 0. Okay, so it is non-zero nilpotent matrix, and this matrix not diagonal. In this result you can say, also you can check by Nbhm. This matrix is not 0, so it is upper term matrix. In case of upper term matrix or lower term matrix, we know that the diagonality eigenvalue. So for this matrix, eigenvalue and diagonality 0 0. Also we know that matrix is nilpotent if only all its eigenvalue is 0. So since the matrix is nilpotent, so all its eigenvalue are 0. It is 2 goes to matrix, so its eigenvalue 2 and 2 also, and all eigenvalue 0. So 2 eigenvalue 0. Both eigenvalue 0. So LG minus 0 limit on 0 will be 2. Okay, and G minus 3 limit on 0. But it will be n. It formalizes n minus rank of a minus lambda. Lambda is eigenvalue. Here n is order is 2. Rank a. Lambda means 0. Because all eigenvalue 0. For in case of 0 I find. Okay, so 2 minus rank a. But rank is 1 because 1 non-zero. So 2 minus 1 will be 1. See, G minus will be lambda 0 1. But LG minus is 2, both are not equal. So you can say that this matrix is not diagonal. This matrix is not diagonal. Okay. So using this matrix you can say that if a to k is 0 for some k integer k, it does not imply a is diagonal. Okay. So this option is correct. Second one says the a square is diagonal. Okay. Using this option you can say also for same example, if you choose a equal to 0 1 0 0, then I have proven that a square equal to 0. Okay, and 0 matrix is diagonal. 0 matrix is Tifr diagonal because the diagonal is 0. So it is Tifr diagonal. Tifr diagonal. So if you choose a equal to 0 1 0 0, then a square is 0 matrix, then it is diagonal. But a is diagonal, a is not diagonal. So it says a square diagonal, then a is diagonal. No. If a square diagonal, then a may not be diagonal. But if reverse true, if a is diagonal, then a square is always diagonal. Because see, if a is diagonal, you can always write. If you always get a matrix P, non-zero matrix, just such that P inverse equal to D diagonal matrix, such that diagonal matrix, such that diagonality of the matrix are eigenvalue A. The diagonalities of the diagonal matrix are the eigenvalue of the matrix A. Okay, P inverse equal to D, such that the D matrix is diagonal matrix which diagonality are eigenvalue of the matrix A. Okay, so multiply D 2 times. You multiply D 2 times, you get D square, D with D square. And in this case, diagonal matrix, if you multiply two diagonal matrix, then just diagonality are square. So you get diagonality lambda 1 lambda 2 lambda n square, lambda 2 lambda n square. Okay, other 0. P inverse P inverse matrix of P inverse P int, so it gives P inverse A square P equal to, in diagonal matrix with diagonality lambda 1 to lambda n square, just diagonal square. Okay, so this implies that A square is diagonal. Okay, because P inverse P is non matrix also, a P inverse A square P equal to diagonal matrix diagonality lambda 1 square, and these are eigenvalues of the matrix A square. Okay, this will imply A square is diagonal. Okay, so if A is diagonal, that implies A square is diagonal, but it was not true. It was not true. If A square is diagonal, then A may not be diagonal. Using this example, you can say, for this example, A square is diagonal. A square is 0 matrix diagonal, but it is not diagonal since it is non-zero nilpotent matrix. Okay, but you can say it LG for lambda 0 is 2, but lambda 0 is 1. Lambda 0 is 1. Both are not equal, so it is not diagonal. Because we know a result, if a matrix n cross matrix diagonal, if only all for all its eigenvalue LG is equal to G1 Okay, so option 2 is incorrect, option 3 is incorrect. Now go through option 4. Option 4 is said it has n linearly independent eigenvector. Okay, it is standard result. If matrix n cross matrix, if n cross matrix has n linearly independent eigenvector, then it is diagonal. Okay, this option is true, but I give a proof, a small proof regarding this. How I can say that? How I can say if A is n cross matrix, it is n linear eigenvector, then it's diagonal. How I can say? Then I am giving a proof regarding this. See, suppose you have n cross matrix. Suppose you have n cross matrix, A n cross matrix. Okay, it has n linearly independent eigenvector. It has n linearly independent eigenvector v1, v2, vn. So if n cross matrix, okay, it is n v1 to vn, n linearly independent eigenvector. Okay, and lambda is the eigenvector corresponding to eigenvalue v1 is an eigenvector corresponding to eigenvalue lambda 1, and v2 is an eigenvector corresponding to eigenvalue lambda 2, and vn is an eigenvector corresponding to eigenvalue lambda n. Okay, so using this you can write AVI equal to lambda I VI for I equal to 1, 2, so on n, right? Because since lambda is eigenvalue, v1 is eigenvector cos eigenvector, so you can write AV1 equal to lambda v1, AV2 equal to lambda 2 v2, AVN equal to lambda vn. So I have written in general form. Okay. So to make A diagonal, I need a P such that P is invertible. So I am choosing my P, this v1, v2, vn. I am choosing my P with column vector, the eigenvector, n eigenvector, v1, v2, vn. Then obviously it is matrix, n cross matrix. Okay, but if I choose this V, then what happen? If I choose this V, then an image effect will happen. What happen? See, given that v1 v2 linear invert eigenvector, okay, eigenvector is non-linear, linear invert. Since v1 v2 are linearly invert, so it will be n vector. So P is n cross matrix whose n column vector are linearly independent. Okay, so obviously it does not imply the rank of P will be n. Okay, because it is n cross matrix, it is n linear diameter. You can thought like identity matrix. Okay, 1 0 0 0 1 0 0. Okay, it is linear invert, all columns are linear invert. Okay, so it rank will be n. Similarly, since P is n cross matrix, it is n linear invert eigenvector, n linear vector in columns. So obviously its rank will be going to n, and since it is n cross matrix and rank is n, that imply determinant P of the matrix is non-zero. Okay, this implies P is P inverse exists. P inverse invertible means P is invertible or P inverse exists. Okay, now if P inverse exists, then if P is this, then what is AP? What is AP? A v1, a v2, a vn, right? Now a v1 equal to, you can write lambda 1 v1, okay, a v2 equal to lambda 2 v2, and a vn will be lambda 1 vn. Okay, I think no doubt. Then you can write like this: v1, v2, vn, and you can write like this. In exam purpose, it is you have to remind this fact, okay, this result. For knowledge purpose I am proving this, because if you are going to prove in this exam, then the exam will be over in one question. Vn to Vn, multiply this, we get lambda Vn first entry, lambda V2 second entry, lambda Vn this last vector, okay. So it is nothing but P, and it is, I name it diagonal matrix with diagonal entry lambda. You can name it D, I name this D. So AP will be becomes P into D, but D is a diagonal matrix with diagonal entry lambda, and lambda nothing but eigenvalue of A, eigenvalue of the matrix A, okay. And I proved that P is invertible, P inverse exists, so I can operate both sides in left right both P inverse. So if you operate in P inverse, you get P inverse equal to INT, so INT into D becomes D, okay. So P inverse AP will be D, where D is nothing but a diagonal matrix with eigenvalue lambda and eigenvalue of A, okay. So it automatically implies A is diagonal, okay. But in this question there is one slightly change. It says diagonal only, there is non-zero matrix P inverse is diagonal, okay. So you can choose for this, if you want to do this format, into you can choose P equal to P inverse equal to Q, or P equal to Q inverse, you can choose. See, if it's P is invertible, then also Q is invertible, because if you choose like this, then you can say determinant P will be determinant Q inverse, and determinant Q to inverse equal to automatically determinant Q to all inverse, okay. This means 1 by, so determinant Q, so determinant P will be 1 by determinant Q, so you can write determinant Q will be 1 by determinant P. Determinant P is non-zero, so 1 upon non-zero is non-zero, so determinant P is non-zero, so Q is invertible, okay. So P is invertible, then it implies automatically Q is invertible. So put here P inverse equal to Q, and you get P, get Q inverse, and D is also D, okay. Now you get the format of that in the question. In question said P in place of Q I have Q, okay, no problem. You have to find a non-zero matrix such that P in place of diagonal. So I find a non-zero matrix Q, I find non-zero matrix Q, okay, so that Q inverse is diagonal, okay. So it implies A is diagonal, okay, diagonal, okay. So fourth option is true. So I can say that if a n cross matrix has n linear independent eigenvector, then it obviously diagonal. So this is the fourth option, okay. So in this question the correct option are option 1 and option 4, and option remaining option 2 and 3 are incorrect. So correct option are 1 and 4, this is correct option, okay. So thank you. If you have any doubt, you can ask in the comment section, okay. You can always ask in the comment section, and if you need any solution of other math from the paper of February 2022, then you can ask me in the comment section, okay. Otherwise I will proceed my own way, okay. I'm starting uploading solution of real and linear algebra. After that I upload the complex analysis and modern algebra, and after that applied portion, okay. But if you to tell me some particular question that you need, then I will obviously solve that question in the next video, okay. So thank you.